All right, hello everybody. Like I said, thanks for joining me here today. Today we're going to be talking about how to read and understand a METAR and a TAF report. For those of you who are new to the live Q&As, my name is Taylor. I am a certified flight instructor out of Southern California, and I just joined Altitude University back in September to help with the Part 107 side of things. So all the material getting you guys ready to take that written test. Like I said, today we're going to be talking about METAR and TAF reports. I did open up the chat, so throughout today's session, if you guys want to throw some comments in there. At the end of this, we're going to be going through the top 5 questions that you might see on your written test, so feel free to throw in your answers there in the chat. And then if you have any questions, whether it's related to today's topic or any other topics, we also have a Q&A section for you to put them in there. All right, let's go ahead and get started. So what is a METAR? Well, a METAR is an aviation routine weather report. It is issued every hour. Typically, you'll see it between like the 53rd, 54th, and 55th minute. But it's supposed to give you the current weather conditions observed at an airport. Sorry, my computer is being... Okay, there we go. So we're just jump right in to start reading a METAR. So starting off with that red section there, it says METAR. Sometimes we'll have what's called a specie. Now, like I said, these METARs are issued hourly. However, if there's a significant change in weather between our regularly issued reports, then we'll have what's called a specie report. Why is this jumping around? Sorry about that. Then we have the airport identifier. So most airports in the continental United States start with the K here, and then followed by the 3-letter identifier for that specific airport. So this is Golf November Victor. I don't know. I think this is Gainesville in Florida, but I would have to double check that. But this is how you would search the METAR, which at the end of today's session, I'll show you guys the website that I use to get this information, but you're going to use that 3-letter identifier for the specific airport that you want the weather information for. Then it's followed by the date and the time that this METAR is issued. So those first 2 digits, the 20, are going to be the date. So it is the 20th of this month that this METAR was issued, followed by the time in Zulu. So this one was issued on the 20th at 1953 Zulu. The Zulu time is UTC time, which is in Greenwich, England. Most aviation reports all use UTC time. So to do the conversion, the FAA has a graph out that tells you based upon where you're located geographically how to do the conversion. Right now where I'm located, it's a 7-hour difference. So you'd have to find out based off of where you're located how to do that conversion. All right, then we have the word auto. So this tells us that this weather report was issued from an automated source. You might sometimes see COR, which means that it was corrected. For example, if the winds were wrong significantly or the visibility, somebody had to go in and manually correct that report. So instead of auto, you would see COR. Then we have our wind direction and velocity. So the first 3 digits will tell you the direction that the wind is blowing in relation to true north. So this is for 240, and then followed by the velocity, which for this example is 15 knots. And we'll go through quite a few examples too, so you guys can see how it's written in a few different scenarios. Followed by that, we have our visibility. Now, this is always reported in statute miles, which is what the SM stands for. And it's either going to be in a fraction or a whole number. So for this example, it's actually 3/4 of a statute mile, so not even a full mile of visibility. Then we have the different types of weather that we might see in our METAR. So starting off, that TS there means thunderstorms, followed by the RA, which means rain. Now, this little plus sign here identifies the intensity of that weather. So because it's a plus sign, we have thunderstorms with heavy rain. If you had a minus sign, it would be light rain. And then if there's no descriptor there, then it's just going to be moderate rain. Then followed by BR, and BR stands for mist. A silly way to remember that is baby rain, but the actual definition for the BR means mist. Then we have our sky condition. So this is going to be our cloud coverage. In this example, we have BKN009, which means broken at 900 feet, followed by OVC, which stands for overcast at 011, which means 1,100 feet. Now, both broken and overcast clouds do count as a ceiling, and your few and scattered clouds are not a ceiling. Then we also have some clouds here identified by this CB, which are the cumulonimbus clouds. And these are the only type of cloud that is going to be depicted in a METAR. Then we have our temperature and dew point, and both of these are given in degrees Celsius. So it starts off with our temperature here. So it's 26 degrees Celsius, and then our dew point is 25 degrees Celsius. Followed by our altimeter setting. So this is used mainly for manned aircraft. We do have an instrument inside the cockpit called an altimeter, and we use this number here. We put it in that instrument. So this just is 29 or 85 for the altimeter setting, not necessarily something that we're going to be using as Part 107 pilots, but you do know how, or you do need to know how to read that for the test. And then followed by our remarks. So sometimes we don't have any remarks, then sometimes you have a ton. So this one is just an example here. It just looks like a bunch of random letters and numbers. But what this means here is that the thunderstorms began at 32 minutes after the hour, and rain began 32 minutes after the hour. Like I said, we're going to look at a few examples, see a few different remarks as well. So this first example here is starting off with that airport identifier. So we always got that K in front there, that kilo, followed by that 3-letter identifier for the specific airport. So it's Mike Delta Whiskey. This METAR was issued on the 4th at 1852 Zulu. Our wind is coming from 120 at 8 knots. Our visibility is 6 statute miles. So this is an example where we have it in a whole number rather than a fraction. Then we have rain. And since we have this minus sign here, again, that describes the intensity of the weather, this means that we have light rain. Looks like we've got a few layers of clouds. So starting off, we've got scattered clouds at 600 feet, broken clouds at 4,700 feet, and overcast at 11,000 feet. So out of these three, what would be our lowest ceiling? You guys can throw that in the chat just to see how we're doing so far on this topic. So between scattered, broken, and overcast in this first example, what is our lowest ceiling? So our lowest ceiling is actually going to be this broken layer here. So scattered at 600, few and scattered do not count as a ceiling. However, broken and overcast do. So broken clouds at 4,700 feet, overcast clouds at 11,000 feet. So our lowest ceiling in this example is going to be that broken layer at 4,700. Then we have our temperature and dew point, again in degrees Celsius. So temperature 21 degrees Celsius, dew point 19. Our altimeter setting 2981, and then we don't have any remarks for this example. Then our second example, again, starting off with that K, our 3-letter airport identifier. This report was issued on the 17th at 1956 Zulu. Our wind is from 180, and the wind is 16 knots, gusting 21 knots. So if you have a gust factor in there, you're going to see that G in here. So we got 16 knots, gusting to 21 knots. Our visibility is 2 statute miles. We've got some light rain again. So the RA means rain, followed by, starting off with that minus sign, which means that it is light rain. We've got BR, which means mist. And then we've got a broken layer of clouds at 1,000 feet and overcast at 2,100 feet. So with these clouds, what would be our lowest ceiling? Perfect, yeah. So our broken layer here is going to be our ceiling, which is 1,000 feet. Altimeter 297.6, and then we do not have any remarks. So both broken and overcast count as a ceiling. All right, moving into, I see somebody raised a hand. I don't know, it went away. So if you want to throw anything either in Q&A or the chat box, I'll take a look at it there. All right, what is a TAF? So a TAF report, it's going to follow the same kind of description as our METARs, but it's going to be a forecast. Now, TAFs aren't available for every airport. It's normally for the larger ones. So for example, the airport that I fly out of, we do have a TAF, but a lot of the smaller airports that I fly to do not. But it is just a forecast. Typically, it's either a 24-hour or a 30-hour forecast, and they update them 4 times a day. All right, starting off, like I said, this pretty much follows the same kind of spread as our METARs with a few different things. So we'll start off, again, we've got the TAF, so it's a routine TAF, or if they need to amend a forecast, you would see AMD, meaning that they're either fixing it or weather might have improved since the last TAF report. We've got that same station identifier. So starting with the K and then PDX would be the identifier for that specific airport. Now, following, you've got the date and time that this report was issued. So this report was issued on the 20th at 1741 Zulu. Then followed by the valid period, date, and time. So it was issued at 1741 Zulu. However, the valid time period for this report is from the 20th at 1800 Zulu until the 21st at 1800 Zulu, which means that this is a 24-hour forecast. We've got our wind. This VRB here means variable. So it's a variable at 3 knots, which means that they're not able to give us a specific direction that this wind is coming from. Then this 6 statute miles here, this P in front of it means either plus 6 statute miles or greater than 6 statute miles. We've got a few different types of clouds. So we've got scattered clouds at 4,500 and broken clouds at 6,000. Then following that, we have a few different forecasts broken down by the hours. So starting off from the 20th at 2000 Zulu, the winds are forecasted to be a 130 at 8 knots, plus 6 statute mile visibility, and broken clouds at 20,000. Then from the 20th at 2300 Zulu, so 3 hours later, they are forecasting that the winds are from 100 at 11 knots, greater than 6 statute mile visibility, with light rain and overcast clouds at 4,000 feet. Following that, from the 21st at 0500 Zulu, so quite a few hours later, they're forecasting the winds to be 120 at 14 knots, greater than 6 statute mile visibility, with light rain and then overcast clouds at 2,500. Now this WS here stands for wind shear, followed by the altitude. So they are forecasting that there's wind shear at 2,000 feet from 190 at 20 knots. Some common acronyms that you also might see in a TAF report is this PROB40. So the probability of that type of weather occurring is 40%. So sometimes you'll see that after a thunderstorm is forecasted. VCTS means in the vicinity of, so you might see that when they're talking about rain showers. FM means from, like we just saw in this example here. And then that P6 statute miles is greater than 6 statute miles or plus 6 statute miles. All right, in this example, so I'll run through this and kind of point out some ones that we haven't seen yet. We don't need to go through each line individually, but starting off that TAF, and this is for Mike Delta Whiskey. This report was issued on the 4th at 1744 Zulu, but the period that it's valid for is from the 4th at 1800 Zulu until the 5th at 1800 Zulu. Starting off, our wind at 220 at 8 knots, 6 statute mile visibility with light rain in the vicinity. That's that VCTS. We've got scattered clouds at 600. We got cumulonimbus clouds. Broken at 4,700 and overcast at 11,000. Then we have this tempo. So they have a temporary forecast, valid from the 4th at 1800 Zulu to the 4th at 2000 Zulu. So for temporarily, for a 2-hour forecast, they are anticipating 4 statute mile visibility. This is rain, and the SH means shower. So they're anticipating rain showers. And broken clouds at 800 feet. All these items following that, actually I'll do the next line because there's a new identifier in there. From the 4th at 2100 Zulu, winds should be 240 at 9 knots, greater than 6 statute mile visibility, and then showers in the vicinity. So that's that VCSH. So sometimes they have it written out like this, and then they had another example up here where they had light rain in the vicinity. So you can see it written either way. Scattered clouds at 1,000, broken at 2,500, and overcast at 6,000. Between these 3 clouds, our lowest ceiling would be the broken layer at 2,500, because both broken and overcast constitute ceilings, and the few and scattered do not. For this next line here, we've got from the 5th at 000 Zulu, winds 270 at 8 knots, plus 6 statute mile visibility. We've got scattered clouds at 2,500 and broken at 6,000. So what would be our lowest ceiling between these 2 clouds here? See if anybody. I will answer that question that you threw in there at the end of all of these slides. Perfect. Yep. So our lowest ceiling between the scattered and the broken is actually going to be 6,000 feet. So scattered does not count as a ceiling, but a broken layer does. So our lowest layer, or sorry, our lowest ceiling here would be 6,000 feet. From the 5th at 0300 Zulu, winds are 300 at 10 knots, plus 6 statute mile visibility. The clouds haven't changed, so still scattered layer at 2,500 and a broken layer at 6,000. Following that, from the 5th at 0600 Zulu, 320 at 8 knots, plus 6 statute mile visibility. A few clouds at 2,500 and scattered clouds at 6,000. Neither of those constitute a ceiling. So they're just letting you know there's few clouds at 25 and scattered at 6,000. And then lastly, from the 5th at 1,400 Zulu, our winds 340 at 12 knots, greater than 6 statute mile visibility, and we've got scattered clouds at 6,000. So scattered does not mean that it is a ceiling. All right, for our first question here that you might see on your written test, in a METAR report, what does BR stand for? Either A, broken clouds, B, mist, or C, baby rain. I will give you guys all a chance to answer that. All right, nice job, everybody. Yep, our answer here is mist. Question number 8, or well, number 2 for us. I think it's 18 in our program though. The only cloud type forecast in a TAF report is either scattered clouds, or sorry, scattered cumulus, cumulonimbus, or nimbostratus. Cool, great job, everybody. Our answer is B, cumulonimbus cloud. So that's what we saw in one of the examples. Sorry, give me 1 second. I was gonna try to show you guys an example of something. Anyways, that was at CB in the report. So cumulonimbus, our answer here. What is the forecast wind for Mike Echo Mike from 1600 Zulu until the end of the forecast? So we've got two TAFs here that give us quite a bit of information. So we're going to be looking at Mike Echo Mike here, and we're looking for the forecast from 1600 Zulu. And it's asking for the forecasted wind. So I'll give you guys a second to try to find that. Cool, got a few answers in there. So our answer is B, variable at 6 knots. So what we're looking for here is got Mike Echo Mike, and we're looking for the forecast starting at 1600 Zulu. So at the bottom here, we got from the 13th at 1600 Zulu. So this is what we're looking for here. And the forecasted winds are variable at 6 knots. So our answer here is B. The wind direction and velocity at JFK is from, so they're going to give us quite a few METARs here, and we're looking for JFK, and they're asking us for the wind direction and velocity. Yeah, one answer in there. Let anybody else answer? All right, so our answer is A, 180 degrees true at 4 knots. So that's where they kind of get you sometimes if it's true or magnetic. They try to make some of the answers really close to each other. So you got to be really careful when reading the answers. But we're looking here at JFK, and the wind direction 180 and velocity is 4 knots. What should you expect if you see a nimbus cloud? We didn't really talk about this too much, but if you've taken our weather course, you might know the answer. Awesome. Yep, our answer here is A, precipitation. So nimbus means rain or precipitation. So if you have a cumulonimbus cloud, you can anticipate that there's going to be rain. The weather report lists the cloud ceiling at 700 feet. What is the highest you can operate your small UAS? Woohoo, looks like you guys have already taken our course on weather. Yep, our answer here is B, 200 feet. So we have to remain 500 feet below the clouds, 2,000 horizontal, and have at least 3 miles of visibility. So if they're calling the cloud ceiling at 700 feet, whether that's broken or an overcast ceiling, you cannot fly your drone higher than 200 feet because we need to remain that 500 feet below the clouds. SIGMETs are issued as a warning of weather conditions hazardous to which type of aircraft? Either small UAS only, large aircraft only, or all aircraft. Which I will show you guys how to find SIGMETs too, aside from. Awesome. Great job, everybody. Yep, our answer here is all aircraft. Perfect. Okay, what is the valid period of the TAF for Mike Echo Mike? So we have the same figure that we were looking at a few questions ago, and it's asking what is the valid period for this TAF? You would find that in the first line of that TAF report. Awesome job. Our answer here is C. So we're looking up here at the top for Mike Echo Mike. And this report was issued on the 12th at 1720 Zulu. The time period that it's valid for is the 12th at 1800 Zulu until the 13th at 2400 Zulu. So this TAF report is a 30-hour report. All right, that was all that I've had for the slide today. I did want to show you guys the website that I use to find the METAR. So it's aviationweather.gov. And we've got a lot of things that we can look at on here. So I'm just going to keep it simple with the METARs, TAFs, and the segments. I'll show you guys how to find those as well. So for the METAR here, you're just going to click on it, scroll down, and then you're going to put the airport identifier. So I'll just do my airport here. And so it's starting off just like we had in the slideshow, starting for the airport identifier, and then following that is all of the remarks and weather information that we're reading in the slideshow. I highly encourage practicing reading the raw form, which is the form it's in right now. And then what's nice with this website, you can also choose the decoded so you can see how well you did, or just use it as a tool until you get really comfortable reading METARs. And then if your airport has a TAF, you can also check mark this here to include the TAF. So it gives you the forecasted weather. If your airport does not have a TAF, this is what it might look like. So if you go to see if it has one, it says no TAF found. So if you are in that situation, the thing we usually do is just use the closest airport with a TAF to get somewhat of a forecast for the weather. And then when I was talking about UTC time, like I said, you do have to figure out how to do the conversion based off of where you're located geographically. But when reading these reports, they give you UTC time here at the bottom, which is kind of helpful. So this is a current UTC time, and it'll help you with that math. And then lastly, we do talk about segments a bit. I know in the program, and it is on the written test, but to actually find those forecasts, you would go to advisories and segments here. Doesn't look like, oh, we got some over in Texas. These are convective segments for most likely thunderstorms, but this is where you would check that forecast here. Again, this report is for all aircraft, so it's definitely something to take a look at prior to operating your small UAS. And then another one that I like to look at is the AirMets, which is just the one below it. Because if we are getting low-level wind shear in the region, then we should definitely take that into account before we take flight with our small unmanned aircraft. So when you click on it, it gives you a description, when it was issued, the valid time period. AirMets are valid for 6 hours, and then it gives you a little descriptor. So airspeed loss or gain of 20 knots or more below 2,000 feet. So we're operating our unmanned aircraft below 2,000 feet. So this would definitely be something to take a look at beforehand. All right, that's all I got for you guys today. I will hang, there was a question in here. Let me pull it back up in the chat. Oops. If you want to put that question in there again, I didn't realize that part of the chat, I guess, expires. I can't scroll all the way up. Because maybe we just had, can a drone be flown in light rain if visibility permits? There's nothing saying that you cannot. You just have to make sure you're maintaining at least 3-mile visibility, or at least the weather being reported at least 3-mile visibility, stay 500 feet below clouds and 2,000 feet horizontally. If you guys have any questions about today's material or even other material that you think of later on, you can always shoot us an email, which is on altitudeuniversity.com, or you can join our Facebook group. So if you're not already a member of it, it's a great resource, not only for the Part 107 portion of things. I try to hop on there throughout the week and answer questions regarding this material, but it's also a great resource to be part of a community of other Part 107 or aspiring Part 107 pilots. People talk about methods to increase, their business or expand their business, different models for a lot of different. Can I rewatch tonight's recording on the website or YouTube or Facebook. All of these are being uploaded to the YouTube channel, so this one should be uploaded later this week. I will double check with David on that, but he's been uploading all the ones that I do so that they will be available on the YouTube channel. Hope you guys have a great rest of your week. Other than that, have a great Monday.